Good morning, everyone. This is the session 10 from the playlist of friction. The topic is friction between the chain and the table. And the question for this session is written on this board. The question here is a heavy uniform chain lies on a horizontal table. If the coefficient of friction between the chain and the table surface is 0.25, then the maximum length of the chain that can be hung over the table is. There are four options here, and we have to find the length of the chain, or you can say the maximum length of the chain which can be hung over the edge of the table in percentage. So in order to solve this question, I have already drawn here one figure in which this is a chain which is lying on this horizontal table. So this is the table. This is the table, and the chain is lying on the surface of this table, and this is the portion of the chain which is hanging over the edge of the table. So here what I have done is I have considered the mass of the chain as capital M, the length of the chain as capital L, and the length of the hanging chain as X. Now here I will be using one this important concept, and the concept is the maximum length of the chain that can be hung over the edge of the table depends on the force of friction due to the chain which is lying on the this table. So in order to find the force of friction, we will have to calculate the weight of the chain which is lying on this horizontal surface, or you can say on the table. So here, if the mass of the chain is M and the length of the chain is capital L, then the mass per unit length, mass per unit length, this will be equal to M upon L. Now the weight of the chain lying on the table, this will be equal to, if the length of the chain is L and the length of the hanging part of the chain is X, then the length of the chain which is lying on the table will be equal to L minus X. Now the mass per unit length is M upon L, and the length of the chain, that is this one, the length of the chain which is lying on the table surface will be equal to L minus X. So this will be equal to L minus X. So this is the mass of the chain which is means lying on the surface of the table multiplied by G. So this is the weight of the chain which is lying on the table. So the force of friction will be equal to, it's equal to mu into N, and this is equal to mu into M into G. So where M into G is the weight of the chain which is lying on the table, so we have already calculated it, and mu is given to us which is equal to 0.25, and mg is the weight, so this is equal to into M upon L, L minus X, okay, I will write it here. So this force of friction will be equal to 0.25 into M upon L, L minus X into G. So this is the force of friction, and this force of friction will be acting in the backward direction as indicated by this arrow, and this force of friction will support the weight of this hanging part of the chain. Now the weight of the hanging part of the chain, weight of the hanging part of the chain this will be equal to mass per unit length into the length of that hanging part of the chain into G. So this is another equation which I have got. So I have got these two equations. Now since the force of the friction will be balancing the weight of this hanging part of the chain, therefore this M upon L into X into G, this will be equal to 0.25 M upon L minus X into G. So from here, from this equation, this G and G will get cancelled out. M upon L and M upon L will get cancelled out. So we will be getting X is equal to 0.25 can be written as 1 by 4, that is 25 by 100. So this is equal to 1 by 4 L minus X. So from this I am getting the equation as by cross multiplication it will be 4x is equal to L minus X, or it implies that 5x is equal to L. Or we can simply say that X is equal to L upon 5. Now we have to find the maximum length of the chain which can be hung over the edge of the table in percentage. So the length of the chain is L, the length of the hanging part of the chain is L by 5. So the maximum length of the chain that can be hung around the edge of the table in percentage will be equal to L upon 5 divided by the length of the chain into 100. So this is equal to L upon 5L into 100, and this is equal to this L and L will cancel out, and 5 by 100 by 5 is equal to 20, so this is equal to 20%. So the maximum length of the chain that can be hung over the edge of the table is 20%. So the correct answer is A, that is 20%. So I hope you have understood the solution of this question. Here the most important thing which you have to remember is that the weight of the hanging part of the chain will be balanced by the force of friction. And by using this concept we were able to solve this problem. So thank you very much for joining this session. In the next session I will be coming up with the another question, or you can say another type of a question, but the topic will remain the same, that is friction. So thank you very much again. Have a nice day. Bye.